Hi everyone, and welcome to the flipped instructional recording for the Unit 2 Teacher Graded Assignment Physical Properties Lab. As a reminder, you do need to take notes during the recording. There will be notes that need to be added to your science notebook, as well as guiding questions that you need to update and answer as well. So if you're able to look at the slide here, just an example, your guiding questions will go here, and your notes will go on the left. As we get started looking into the lab, it's just a reminder that we're collecting our information in this section, and then we're filling out the lab report. I do encourage you to print out the lab report page and write all over it, answer your questions as we go. And that way, at the end, if you want to type it, then you can always submit handwritten work as well. So as we get into the introduction, there's definitely some things we want to remember. So physical properties can be used to identify pure substances. So in this lesson, you will conduct an investigation to determine the identity of unknown substances based on their physical properties. So here's our lesson goals. So you don't need to copy those or put them in notes or anything. You do need to define physical properties. That's the properties of a substance that can be observed without changing the chemical makeup of the substance. And your guiding questions that we're trying to answer. As we go through the first few slides, you'll be able to answer all of these. So have your notes out, and remember, what I like to do is just take a little screenshot and I open up a new Word document and just paste those there so I can keep it open over to the side as I read and answer those questions as I go. All right, so as we get started, the first thing we are talking about are intensive and extensive properties. So pure substances have characteristic properties. Each pure substance, so that means like an element, and so think about an element of gold or oxygen. So something that is a pure substance has characteristic physical and chemical properties that can be used to identify it. Atoms and molecules are too small to see, so we must rely on indirect observations related to the properties of substances to identify things. Physical properties can be observed without changing the chemical composition of the substance. So again, in your notes, you can either copy that down or use that little snipping tool, the light shot or the snipping tool, and you can add that into your notes. This would also be a good thing to add into your notes so that you can see the differences there. So when you're talking about intensive properties, they do not depend on the amount of the substance. So whether we're talking about, in the example here, it says a tablespoon of water or a gallon of water, the boiling point of water is going to be the same. So the same is true for density. Other properties are extensive, and that means they change based on the amount of the substance. So that would be something like the mass of gold, right? The mass of gold would be bigger the more we had. The volume, the length. So these are measurements that you're taking. Those are all examples of extensive properties. All right, so as we move on, we're talking about density being a physical property, and it's the mass per unit volume as shown in the equation. So I think this page is a great thing to have in your notes. The formula for density, understanding density equals volume divided by, or mass divided by volume. You can see it here. Also, this image is really great. You can see that these are the same size, but this object has a higher density, so it's heavier. And kind of explaining that, the units of volume, okay, the volume of this is basically like how much does it contain. So if it's a solid, it might be grams per cubic centimeter. If it's a liquid, it might be grams per milliliter. So those would be the units of measurement you would use. So objects with a larger mass per given volume, so this would be mass per given volume, right, have a higher density. So for example, a kilogram of feathers and a kilogram of lead have the same mass. They're both a kilogram, but the lead is more dense. So think about this being the lead and this being the feathers. If it was 1 kilogram, your scale would be balanced, but you have more density here. There's more packed into the lead. It's more dense. Okay, so as we go on, it also talks about getting the volume of an object. You use this formula, length times width times height. So if you're looking in the example here, you have a perfect square, which means all the sides are equal. So that makes it very easy to find the volume. So in the experiment, we're going to use physical properties of some metals to identify the unknowns. You will make measurements using tools in a simulation and make a claim about the identity of the unknowns supported by your data. My computer's moving slow today, so it's thinking about, there we go. All right, so the first thing I would do is go ahead and open up your lab report, either print it out or have it open to the side so that you can start writing down answers even in rough draft form as we go. The other thing is at this point you're able to have all the guiding questions answered. We talked about the difference between extensive and intensive properties. 2, we talked about density, so that definition can go in. Guiding question 3, how to calculate density. So we saw that formula, easy to answer that. How do you calculate volume? We just saw that image as well. And the purpose of this experiment. So you're able to go to your science notebook slide, answer all those guiding questions, put all your notes in, and be done with the notebook slide so that you can move on to your lab report. So you want to open up your Word document and be ready to go. All right, so as we get started in the investigation, we're seeking to answer this question. What are the identities of the unknown metals? So if we look in our lab report page, question 1, what's the purpose of the experiment? So we just saw that, and you could go ahead and fill in that answer. As you work through the investigation, you should gather evidence to support your claim that answers the question. So from here, this is the simulation page that we're using. Just to kind of make it a little more clear if you're having a hard time understanding what we're doing, we've got 3 unknown metals here. We have 3 metals that we do know here. So we know that silver is going to have certain properties that are specific to silver that will help identify it. One of those being its density. So the same for all these other elements. So every pure substance has characteristic physical properties that can be used to identify it. The blocks in the toolbar, okay, up here, are either silver, tungsten, or platinum. So we're going to use the tools in the simulation to identify the type of metal in each block in the toolbar. And you can assume all the blocks are perfect cubes. So in doing that, you might think, how would we figure out what, each of these blocks are? We talked about the physical properties that we were able to use to identify, and we know that density is one, and we know how to calculate the density. So we just need the mass and the volume. So we are able to get the mass on the scale and the volume by measuring one of the blocks. Well, we'll measure all of the blocks, but we'll start with the ones that we know. And so we're able to calculate the density. So before I get started doing any of this, you are going to need to create a data table showing this information. So the easiest way to do that, you can do this if I make a new PowerPoint slide, I could show you a table easily. So if I go here and make this blank, and sometimes it's easy to insert. Sorry, there's a line where it's recording and it's kind of blocking what I need to see on this. So I'm going to have to move it over really quick to be able to edit it. But I want to get a table. Here it is. So maybe if I make it a little bit smaller for you guys, that way you can see where I'm getting this. So if you create it in a PowerPoint slide, it was an easy platform to create it, and then you could copy and paste it or take a screenshot and paste it into your Word document. So if you create a table, okay, you would insert a table. You could do it on a spreadsheet too if you wanted, but this is the harder part for students sometimes. So the columns we know go up and down, right? And we're going to have our substance is 1, the mass, the length, the width, the height. So basically the volume, so that's another one, and then the density. So we need 1, 2, 3, 4, 5, 6, 7 of these. 7 columns. Okay, then you'll need 1 for your title, right? If we're talking about rows, we need 1 for our title. We need silver, tungsten, and platinum. And then we also have 3 unknowns. So that's going to be 7 as well. All right, so now we have a table and it's editable. We can make these bigger if we need to. It'll let us spread them out however we need to adjust. Sometimes you have to play with it a little bit. But up here, this would be the substance. This is going to be the mass. Oops, typo there. Mass. So see, I need to make these all bigger. So here we would get the length. Then we have the width. We have the height, which gives us the volume. And then we're able to calculate the density. So you'll kind of see really quickly that really we only need 1 of these, length, width, and height, in our data because it's a perfect square. They're all going to be the same. So we're starting out with, we'll fill this in. We have silver, we have tungsten, and we have platinum. You may know platinum because it's common. Jewelry is made out of platinum. Silver, jewelry is made out of some silver. So, and then we have unknown, 1, and then I'm just going to put UNK 2, unknown 2, and unknown 3. All right, and so we're going to want to fill this in as we go. So you'll want to write these down, but I just wanted to show you a quick way to make a data table if you didn't know how. Just open up PowerPoint and you can do that. So I'll kind of pop this back up as we go. So platinum, we've started out, we've got it's 72.4 grams and it's 1.5 centimeters. So if we're recording its height, 1.5. So if we go back here, the other thing you want to include is in the mass, you need to put grams, and we're getting the height really here. So that's going to be in centimeters. Okay, so this was platinum 72.4, and the height is 1.5 centimeters, and it's at the top, so you really don't have to put the unit of measurement if you don't want to. So to find the volume of that, you have to multiply. So all of these would be 1.5, right? So now we would multiply length times width times height. So 1.5 times 1.5 times 1.5. So that's 3.375. You could round up to 3.4. 3.4, that would be your volume. Okay, so volume 3.4. And remember that we're talking about something that is solid. So this would be volume is grams per cubic centimeter. And I can't make the little cube up there. I mean, I can, but it takes a lot of time and I'm trying to hurry. So 3.4. And so then we're calculating the density here. So density we know equals mass divided by volume. So you take the mass, which was 72.4, and you divide that by 3.4 to get a density of 21.29. So 21.3. Okay, density. All right, so we're ready to go on. Let's go back. And we're going to do this for the tungsten, and it'll move a little faster now that we have everything set up. So this is 65.1 and the same 1.5. 65.1. We know that all of these are 1.5. So all of these volumes are going to be the same. They're going to be 3.4. Okay, and then if we do that division, we have the mass 65.1 divided by 3.4. It's 19.14, so we could put that in 19.1 or 0.14, however you want to round it. And then we're ready to go on to silver. So we'll move this. Oh, we moved everything, my goodness. All right. So now we can see that silver is 35.4. Our scale is back in the right spot, so it's 1.5 as well. So 35.4. So we go back here. And for silver, 35.4. 1.5, 1.5, 1.5. And now we know this is 3.4. So now we can calculate density. We take the mass, which is 35.4, and we divide it, mass divided by the volume, 3.4, that equals 10.41. All right, so looking at these three objects, we can see that platinum is the most dense and silver is the least dense. So we've recorded that so far. All right, so let's take a look at where we are in our lab report. So which properties are more useful in determining the identity of an unknown substance, intensive or extensive? So if you remember, intensive meant it doesn't change depending on the amount. So that's going to be a factor. And the other thing is we're looking here to create our hypothesis. So our hypothesis is going to be something along the lines of an if-then statement. So remember, in your hypothesis, you're making a guess or a statement on what you think is going to happen based on your testing. So if I can determine the density of the unknown object, then I can compare that to the known object and find out the substance. Something like that. You're writing out how you feel it'll come out with your testing. So if I do this, then I should be able to do this. So you'll write that there. What tools did we use? So here, very easy. We had a scale, we had a ruler, we had the virtual simulation, and then describe our procedure. So basically, you're just going to go through and list out. I think it's easiest to just number. Step 1, I did this. Step 2, I did this. Include everything from weighing things, creating a table, list all of that out here. And then this is where if you go in and you make that bigger in a second, I can show you. I'll just snip that and drop it right in, and then we'll keep moving on. All right, so we're going back into the lesson really quickly, and we're going to, we know all of these, so we're going to get them out of the way. And now we're going to start dealing with these unknowns. Okay, so as you bring them down, they kind of take the shape of the other elements or the other samples that we've been using. This one looks a little bit bigger and it's a little bit heavier. So that might be a factor in what we're looking at. Is it's going to be hard to get an exact measurement here. We can put it right up against it and see if we can get something pretty close. So we've got, let's see, 112.6 is the mass. And then luckily, these are all in units of 10, right? So this is going to be 1 point, we know this is 5, 6, 7, 8. I think it goes to the 8. So 1.8 centimeters. All right, so sorry, going back. We're going back to our data table here. Let me get that back over for you guys. So unknown substance for the mass, we have 112.6, and then 1.8, 1.8, 1.8. So the volume, if you multiply that, 1.8 times 1.8 times 1.8, that is 5.83. And the density of that, if you divide 112.6 divided by, so we have the mass divided by the volume, 5.83, equals 19.3. All right, so we're ready to go back to the unknown substance 2. So we have, this kind of grows when you get it out of its little box. Our scale keeps sliding over, so let me see if I can move it. All right, so we have 111.7 grams, and our height here is 2.2. Okay, so if we go back to our data table, we have 111.7. This was 2.2. So if you multiply those three, 2.2 times 2.2 times 2.2, you get a volume of 10.6. And you get a density, when we divide 111.7 divided by 10.6, we get a density of 10.5. Whoops, 53. All right, so go back and test our last one, which is the little one. Okay, and we have grams, the mass is 2.7. We'll scoot it over here close to the ruler there, and it's 0.5. So it's not a full centimeter, it's 0.5, so half of a centimeter. So if we go back, we are entering 2.7 grams, 0.5, 0.5, 0.5. So if you, whoops, got extra space in there, got in a hurry. Okay, so you multiply those, length times width times height, you get a volume of 0.125. So when you take 2.7, the mass, divided by the volume, you get 21.6. Okay, so you can kind of start to look and see comparisons of things that are similar. So you have silver at a density of 10.41, and the unknown of 2 is 10.3. The density of tungsten is 19.4, and the unknown of 1 is 19.3. So those would be very, very similar. Remember, their sizes are just a little different. And then unknown of 3, you've got platinum at 21.3, and the unknown of 3 is 21.6. So that tells us that unknown 3 is platinum. So we want to be able to now put this in our assignment. So just take a little screenshot, a little snip of it there, and copy that. And we want to go into our assignment and just paste it in. So it was a little big. We can size it down And it should, if we size it down enough, it should pop up. Yep, right into our assignment page. So now we have a nice, neat table. Everything's labeled, and we're ready to go on to our conclusions. So now it's asking what type of conclusion can we draw about the identity of the unknowns. So here you need to, basically that's saying, what are they? So you need to type out, using your data above, what did we find the unknown of 1, 2, and 3 to be? So you would type that out, and then you write an evidence-based claim, meaning I know this because the density of silver is this, tungsten is this. So you're able to basically offer proof, evidence-based claim. All right. And then for the second part of that question on your conclusion, it says evaluate the procedure used in this experiment by considering the properties used to identify the unknowns and the number of knowns that were tested. So let's break apart just that sentence first. The procedure that we used was we found some extensive properties, right? We found the mass, length, height, volume. Okay, we did extensive, but we also did intensive, where we found the density of the known substance. Okay, so it's saying, what properties did you use to identify the unknowns and the number of knowns that were tested? So basically, in this case, we just did density. Revise the experimental design by proposing ways to modify the experiment to increase our certainty in the identity of the unknowns. So we talked about, if we go back to that page where I said snip that little chart on intensive properties, we could test the boiling point, like when does it melt, the melting point, right? Those are metals, so they're going to melt, they're not going to boil. We could test the color, right? We could write down the properties of color, melting point. There's all kinds of properties that we could add and write down and get that from just looking at it. And if we were thinking of a real life experiment, and we had those metals in our hands, would they be shiny? That's a property. Dull. Is it malleable? Is it able to bend easily? So all of those things are different physical properties that we could add to our testing. So not only know the density, but if we also know that the density is 21.3, the color is, silver, and the melting point is so many degrees, then we could even be more sure of the element that we're identifying. So your answer to number 2 needs to be something along those lines. So not exactly what I said, but something along those. So that takes us through everything on the lab report. I've also showed you how to put in a data table. There is no need for a graph on this one. We're not graphing anything. And be sure to save this, and then you'll be ready to upload it. So got a lot of stuff going on there. Let me clear out. But we've gone through the virtual experiment, and so now you should be all set in submitting. If you have any questions on that, just let me know, and I'm happy to help you with that. So your next steps from there would be, 1, to get your lab submitted. Look for our Flip follow-up. If you need me, you can come into Help Lab or message me on Skype, send me an email. Have a great day.